Welcome to Callous Coder, and today we will be coding like it's 1989, courtesy of a great video from Adrian's Digital Basement.
So the computer always seems to boot up in the slow speed whenever you boot up. But what's cool is on this documentation that I found, it says that the BIOS writes 0 for slow speed or 1 to fast speed to the IO port CF. And we can do that ourselves using the debug command. Redirect the file like fast.d into it. And what that's going to do is it actually just executes the commands. I had a comment from Jaser. He said it would be pretty easy to create a COM file using debug where we could actually change the speed of the computer without needing to run it through the debug command every time. And I'm going to do the same thing quickly for slow mode. So I have two COM programs, one to do fast and one to do slow. Taking a look at the power LED, it's green right now, which I think means we're in fast mode. And if I run slow, I'm just going to type the command slow, hit enter, and it's changed to red, which means it's in slow 4.77 megahertz. And we type fast, and there it is, back to fast. And that's pretty cool. It's fantastic. Thank you, Jaser.
First of all, Adrian, thank you very much for this nugget of knowledge. I wasn't aware that you could actually redirect assembler code into debug. I did program in debug a lot, like the other subscriber did, writing the fast.com and the slow.com. And it made me think, writing two tiny little programs, a couple of bytes each, brought another different problem that we had back in the 80s. That was storage. 1 byte would consume a whole cluster, and a cluster was like 4 kilobytes, I believe, or 2 kilobytes. So I figured, like, let's make a COM file that is a bit bigger, that also actually writes stuff to the screen and toggles turbo on and off. And I'm going to do this unscripted, unrehearsed, live on camera. So bear with me if I stumble across my words. I will be actually commenting the code later on, because I don't want you sitting through me typing and also tripping over the keyboard, as I will already trip over my words. But let's jump in and let's code like it's 1989. So first and foremost, we have this little bit of boilerplate code that I already wrote up. This is to satisfy TASM, and I will make sure that there is a download of my whole DOSBOX directory that has TC, Turbo, C++ installed and TASM, so you can literally walk along and do as I do. Now the dot model tiny creates a COM file. A COM file is 64K and only has one segment. .exe files could have different segments, like your data segment, your extra segment, your stack segment could be in different 64K blocks, because there was no contiguous addressing in DOS. But we're keeping it simple. We're going to make a COM file that has all the data in the same data encode in the same 64 kilobytes. We're going to use the data segment. This tells where the data can be found, which is in the same block. And we set up our main. Basically, this is your entry point for the code. Now first we're going to make a little subroutine to exit, and we can call a subroutine with, let's make it a capital, with the keyword call. Call as an operation on the processor, and it will basically jump to an address, but there is no address yet created, so we need to create that address. How do we do this? We call this exit, and it's a proc, just like main, exit proc. I can type wonderfully well in this editor, as you can see. And exit NP. How do we exit DOS? Well, DOS has what is called DOS interrupts. It is this list, or this is a subset, it's a big list. And basically it says, in the AH register, we put the value 4C, and then we call int21, because this is int21 DOS functions. So in AH register, AH, comma, 04C hex. I always add the 0 to make it consistent, and we call integer 21 hex as well, and see if this compiles. It should compile or assemble and link. Yes, we want to override it. I have a convenience bed file that's called C for create a com file, and you just need to type in the name without the extension. And as I said, I will put down my whole DOSBOX directory that you can download and you can code along if you like. And apparently it's doing okay. It just doesn't link. Invalid entry point address. Fascinating. Invalid entry point address. What am I doing wrong here? Let me think about this. I'm in code. I am missing. Ah, right. I'm in code. Yes, I'm missing the org 100 hex. A com file always starts at 100 hex. Below 100 hex, and it's ironic that I forgot this because we're going to use that, is the PSP. The program subscription pointers, I believe it was called. It's a long time ago. Doesn't matter. It basically tells how the program needs to start. So now it should actually compile or assemble and link. If I say compile, just think assemble. There we go. It starts turbo and it exits right away. So we have the first method created. How easy is that, right? Now we need to have a method of reading the command line arguments. How do we read command line arguments? Command line arguments in DOS are located on offset, data segment offset 80. And on 80 it tells you the number of bytes, and it can be a maximum of 128. So if I say move, and let's use CL for example. CL is also a register. Registers are basically comprised, that is a good thing to talk about. If we have AX is built up of AH, the high byte, and AL, the low byte. CX is built up of CL, the CH, the high byte, and CL, the low byte. BX, BH, and BL. And those are basically the ones that we use the most. We also have DX. We're going to use that as well here. DX is DH and DL. So if you see CL, I'm using only 8 bits of the 16-bit register. So move CL with square bracket. That's a new one. 80 hex. Or if I'm going to be very correct, it is actually DS colon 80 hex. Now, what is the square bracket? The square bracket basically says go into memory at this address, or where this address is pointing to, and get the value from that. See how easy assembler is? It's really not that hard. Then we need to compare, basically do an if statement. Compare CL to, in this case, it's 2, because what we're going to do, let me show you for a second. Save, quit. Let us build, see if we're doing anything wrong. It's satisfied until now. Cool. What we're going to do is we're going to call turbo 1, that should enable turbo. Turbo 0 should disable turbo, and turbo without anything should write a usage string code. That is basically our approach. So we got 2 in there, and then we can actually jump if is not 0. What compare does is basically subtracts, in this case 2, from the value that is in CL, and if that is 0, it will set the 0 flag. It will not update the CL, by the way, or the register. It will just do the subtraction, and if it's 0, it will set the 0 bit. And then we can jump to, for example, a label. And let's jump to error. We don't have any error yet, but let's do the error here. Error. So if it's not zero, then we go to error and we will print out an error message. Let me explain why this is 2, by the way. I didn't do that. Oh. Let me go back to DOS and explain you why it is 2. I said we're going to run turbo with a space and a 1. The space is 1 character and the 1 is 1 character. So hence it's 2. It's not 1, it's 2. It's a bit confusing. In higher languages you will get actually the number of arguments based parsed on space. Not in DOS, not from the command line. So hence 2. And let's make a little message. We put it on the data, so we're going to make a string. And let's call it T-error. T-error. DB, it declares a string basically, declare bytes. And let's say usage colon turbo 1 or 0. And we want a new line, character 10, and a character return. And the strings need to be terminated with a $sign, because then we can use a print line, basically, a write line method, which we see over here, write string to standard out, which is AH9. And it uses the entry level DX. So let's make a function that we can call several times, because we will use print many more times. So let's call this print. It's also a procedure. Print end procedure. I don't like this syntax at all, but it is what it is. End proc. How many times I do something wrong in there. End p, you see, it's incredible. So the documentation says we need to have AH loaded with 9 and DX pointed to the string that is terminated with the $sign, which we did over there. Okay. But we want to print many different messages, so we're not going to set AH here, we're just going to set 09 hex and call, what is the call? It's interrupt 21. And that will tell DOS, okay, we're going to print the line, but we need to print the line where it's pointed to. So here on the error, we load. We can do this in different ways, but let's not introduce new things. Load dx, comma, with offset. Offset tells the compiler that we want to have from ds with this where the terror is. Terror. Where was it? Where dx here. Terror. And then call print. Oh, I did it with caps. It's a convention that I've been using for ages. Compile this and look at that. It starts it. It has no argument and it basically prints this message. It basically prints that message. Wow. But if you see, if I do this or this, it's still not doing, but we're making progress. So when we say it is 2, now we're basically in this code block, but we keep running here, and that's why we call exit. Let's also call an exit here. And let's make a nice little label for just readability. No, I'm not going to do that yet. I'm first going to check the value in 82, because that is, as we see, it's it says from 80, and it starts at 81, the command line arguments. I'm not saying this right. 80 tells us how many bytes are in the command line argument, and it starts at 81. So basically it is 81, 82. I hope I explained that correctly. It's just basic pointer arithmetic. It's not really that hard. So let's move CL with the value that is in DS 082. Right, so what is in memory on address 82? And we know 80 tells us there's 2 bytes in there, and we start from 81, so that's 81 plus 1 is 82. It's easier than to explain it, to be honest. And we compare it to the character 0, because this is not the value 0, but the character 0, because on the DOS prompt, when we are here and we do this, it's the character 0, not the value 0. But luckily the TASM and MASM, all assemblers are clever enough that if you put it into single quotes, it will find the ASCII value and compare against that. Now, if it is equal, we will jump, if it's not equal, in this case, because we're checking 0, we jump to turbo on, which we do not have yet. So this will be turbo off if we continue on. If you continue on, this will be turbo off. And let's make a turbo on here, where we will end up. Turbo on. Interesting stuff. Let's first go to the turbo on. We saw in the video that we needed to put in the value of what was it? CF. We need to output the value of CF. Let's make a function as well, but let's say if we remove in AL the value, and the value is 1 for turbo. Let's keep it consistent. Call set turbo V, turbo value. Not really a nice name, but it will work. Let's create a different method so that we can use our function turbo value, and it is of course a proc. I told you I do this wrong all the time. Turbo V and proc, and let's start adding some remarks in here as well, because we know that print prints the string where dx is pointing to. Writes the value currently in, shall we do, what was it, AL, I believe, currently AL, yeah, to port 0 CF, right? Yes, that was CF. Okay, cool. Now, the funny thing about writing to ports is that you cannot do that directly. It needs to go through the DX. So we first need to set DX with the value of CFH. You can find that in the documentation of the CPU. It's something I remember from all these years of doing it. Move DX, AL, and we set AL before we're calling this function. So this technically should set the value. And I'm doing something very, very wrong. I realized that I was already thinking like, I'm doing something wrong. You need to add a RET, return, because that tells in a subroutine, if you're done, return to where you called it from. And you see, assembler is very forgiving. You will just chuck on nicely, but you will get errors at due course. And trust me, those are not fun. Those are not fun. Why is my tab here not as far? Okay, let's clean it up nicely. Okay, and what I also like is indent. Readability is very important in assembler, because as you can see, it gets cluttered quickly. It's not that hard to code, but it's more difficult to read. Call, DOS, exit, and close program. So there we go. And let me check. We move CF, that is for that Compaq that we saw in the video. And we have the value there. Okay, so we can call, we load it with 1, so we set the turbo on. What I also like is call a print statement, call print, and say that the turbo is being set on. And we said we need to move DX offset to, let's call it T on, turbo on. I like to keep the names small, and let's create a string T on db turbo on. Carriage line, new line, carriage return, and terminate with $1. So let's see what we have now. File, exit, save, C, turbo. And we have an error. Error at line 37, extra characters online. So 37 extra characters online. What is extra character here? Oh yeah, I see it. The colon. That is compiling. Okay, cool. And if it is 1, does it find it? Turbo on. There we go. And we know that it set the value in that port. Actually, we cannot test it in this DOSBOX because it doesn't have that logic in the hardware, but we can assume it's working. So we have the on situation. Now let's code the off situation. See how easy assembler is. So we have turbo on. Let's do the turbo off here. And then we need to move AL with 0, right? And call turbo value, set turbo value, but otherwise it's too long. And let's also make a nice little descriptive text. Offset T off, call print. And actually I'm going to... is it worth it? Nah, I will just call the exit. Keep it nice and simple for you guys to follow along. What I was thinking about is actually I could make a jump to a label called exit and jump to there and call it. But yeah, I may as well do the call here and it will do implicitly the jump. Doesn't make that much difference in bytes and speed. And I like to have my method names in capitals in this case, because then I know it's a method. And we need to define the turbo off string. So T off db comma turbo off comma 10 comma 13 comma $. And you see what we're doing is a very iterative process, and that is very important in assembler programming. Write little chunks of code and test them immediately. First and foremost, they compile almost instantly, even on old systems, and that it prevents you from writing chunks of code that do not work. Turbo off, okay, turbo on, right? So the last case is when we do not Do that, it writes it. Yeah, so we have everything coded. Now the funny thing is, how big is this program? It's tiny. It's 115 bytes. It's 115 bytes only. That is really small. Now ironically, it is 115 bytes in memory, but on disk it still takes a cluster. And correct me if I'm wrong, I believe the standard cluster size in DOS on FAT12 is 4 kilobytes, so it still takes you 4 kilobytes of storage. But as we saw in that C application from Adrian's Digital Basement, that was 6 kilobytes, so basically that would take 2 clusters, 8 kilobytes. So we're saving one whole cluster and a shitload of memory, which back in the day was a thing, but yeah, it only ran one task. So I commented the code. It's now on GitHub. You can download it. I also put in a DOSBOX zip with my environment on there. So you have Turbo C installed. Actually, we didn't code in C, but we used TC, which is Turbo C, as the editor. And I also have TASM configured, plus the C bed file that creates a COM file, plus the B bed file that creates an exe file. So you can jump in right away and code along if you like. And I do urge you to actually get your feet wet in writing assembler code, especially when you're a young programmer starting programming, because you will find that learning assembler, even the tiniest bit, will help you understanding higher level languages and be far more efficient of a programmer. So I know this was a very long episode. I hope that you managed to sit through there, and if you did, see you in the next one.